resulting vectors to work together against each other. So we're going to do force vectors here, which is a push or a pull in a direction, basically. So the velocity vectors were obviously a speed and a direction. So the push or pull is the magnitude in this case. So let's say you're lifting a box, right? So you have the gravity working against you, and then you are putting a force to lift it off the ground. So there's two forces, right? And you're going to hold the box still. So the question is, if the box is being still, what is the resultant vector? Well, that would be the zero vector, because you're neither, it's not essentially moving is what ends up happening essentially. So it's 0I plus 0j. But not every resultant vector is 0, right? It could be something else. So let's take these two forces here, F1 and F2. Okay, so we'll do a little math type here. So we got F sub 1 and F sub 2. Okay, we'll move these to the center. Okay, perfect. So the first vector is 10 pounds. The second vector is 30 pounds. Just because they're 10 and 30 doesn't mean you can add them together, a resulting vector of 40 pounds. That's not how it works, because they're not in the same direction, because the first one is north by 20 east, the second was north by 65 east. So they're going to also offset each other and work together because they're not in the same direction, essentially, right? Okay, so this first one is going to be 10 times the cosine of an angle, I, plus 10 times the sine of the angle, J, and we'll set that to the correct symbol, style 2, style 2. Okay, so I'm going to copy this and paste it, because the second one is 30 pounds, right? Okay, so the question is, what is the angle we need to do? Well, if you're north by east, this is north, this is east. So if I go 20 degrees, that's 20 degrees. But that's the bearing, that is not a trig angle. Bearing is not the same as trig angle. The actual trig angle is this one, correct? From the x-axis, right? So 90 minus 20 is 70, correct? 70. All right, and north by 65 east, so that is the 65, right? That's 65, correct? So this is the trig angle, which is different than bearing. So, excuse me, 90 minus 65 is what, 25? So this is 70. 70. Oh, I'm going to put the angle. Specify it as degrees. Okay, we'll copy that. Paste, paste, change it to 25. Okay, so those are the individual vectors. So the resultant vector, so we'll copy that, paste, paste, paste. So if I add the two vectors together, I will get the resultant vector essentially, right? So I'm going to take the brackets here, and I'm going to add this a value plus this a value to get my I component. And then I'm going to add this b value plus this b value. And that'll give me my j. Okay, so my resultant vector is approximately some value. Okay, all right, let's go to the calculator here. So 10 times the cosine of 70 plus 10 times the sine of 70. No, what am I doing? Cosine of 25. This is 30. Okay, sorry. Because the a value of one plus the a value of the other. Okay, so all I have to do now is copy this, paste this, and do the sign. And the sign, and I get that value there, 30.609, 22.075. So 30.609. Right, 30.609. Yep, 22.075. Hit the J. That is the result vector. Okay. All right, so the two things we want now are magnitude and direction. Whoops. Magnitude and direction. All right, so that's a resultant vector there. Well, we'll keep it like that. All right, so equals, and we will put the little magnitude symbol around it, right? So that is the square root of the x direction squared plus the y direction squared, which would give us some number of pounds. So just because the original were 10 and 30 pounds does not mean the result is 40 pounds, because they're going different directions, right? So it's going to be offset essentially. Okay, so square root, parentheses, the a value squared plus parentheses the b value squared. So that's about 37.739. So 37.739 dot 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 pounds essentially. Okay, direction will be the next part. Okay, all right, so this is our resultant vector of them two things pushing or pulling together, right? That is the resulting magnitude. So now it's a question of what direction. So they were going, 70 and 25 degrees, right? So what's the resulting degrees as a result, because you're adding them together or combining them together. Okay, well that will be the tangent of the angle, which is this value divided by the other value. And you're asking yourself, why is that? Well, let's do a little drawing here, right? So this is my vector here, correct? That's my vector, resulting vector. So if I draw here, this is my resulting vector, FR, correct? And if I, not to scale obviously, as the terminal point there, which is 30 point something, right? And this is 22 point something, correct? So this is the 30 point something here, and this is the 22 point something here, correct? So this is the angle I'm looking for. This is the right triangle, obviously. So this is the opposite, and that is the adjacent, which is tangent, basically, right? So that's why you just use the vector numbers with the tangent to figure out the angle, basically, because those are the opposite and the adjacent every single time, essentially. Okay, so if we do the trigonometry, that means theta is going to equal the inverse tan, because I need to get the tangent off the left side, right, of the parentheses of that value. Because obviously if I do inverse tan to this side, it gets rid of that, and then inverse tan to this side will give me this. So that means the tangent is approximately equal to some angle the calculator will give me. Okay, so tan inverse, ratio. Okay, so I need the sine value over the cosine value. So I get about 35.79. We'll say 35.8 for 35.799 dot 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 degrees. Okay, And that is the trig angle. That is not bearing, essentially, right? So you have to think about what would the actual trig angle be. So if this is my vector, right, and that's the 35.8, correct? That is theta. That's not the bearing. This is the bearing here, which is north by east, right? So you have to subtract it from 90 to get the actual bearing over here, essentially, right? Okay, so we're going to do 90 degrees minus 35.8 degrees. I'm just going to round it off for argument's sakes. So that would be what, 54.2 degrees? And again, that's not the answer because we have to put it in terms of bearing, which is north by that number of degrees east. Okay? So, if you have two vectors, right? Okay, you have this vector and this vector. They're in different directions and different amounts. They're not going to just simply be added on together, right? What's going to happen is, right, if you move this one over to here and you do the tip to tail method, you'll get the resultant vector, which is a new direction and a new number of pounds because they're going to either partially work together and partially work against each other because of the different directions, essentially. So it's actually going to result in this pounds in this direction, essentially, when they're both pushing or pulling together on a singular object, whatever that case may be. Okay, let's try this again. So the next page, we have two forces act simultaneously on an object with a magnitude of 30 pounds and 60 pounds. It's south by 10 degrees west and south by 6 degrees west. Determine the resultant vector, basically. Okay, so let's go back and cheat here. And we'll simply steal these. And paste here. Oh, that's not what I want. Okay, so this is 30 degrees this time, and 60 degrees, or 60 pounds, sorry. We have to figure out the degrees, essentially. Okay, so if we figure out the degrees, right, this is south, and this is west. So if I do 10 degrees, right, that's here, I have to go all the way around, right? So that's 90, 90, and 80, right? So that'd be what? 260, correct? And this is south by 60, right? So this is 10 degrees. This is 60 degrees, right? So that would be 90, 90, and 30, right? Or 180, correct, plus 30. Which would be 210, right? So this is 210 here, correct? Okay, so essentially drawing this, you would get that, right? Okay, so let's put the angles in here. So I'd say it was 10 degrees, so 90, 90, that's what, 260, right? And then 180 plus 30 would be 210, because again, the bearing and the trig angle are two different things, okay? All right, so resultant vector is force 1 plus force 2, which is going to give me the resultant vector. So that is a component plus a component. And then b component plus b component, j. Okay, so the resultant vector is approximately something, which we'll figure out here with the calculator. Okay, so Alright, so let's go up here to steal this. Maybe easier. Try to redo the... Okay, so this is 30 and 60, right, for this one. And this will be 260 and 210. Okay, approximate that. And then we'll take this, copy, paste, and do sine and sine. Approximate that. Okay, so we have two negative values, which is fine. So we got 1, 7, and 5, 4. That seems good enough. Okay, so negative 57.17 dot 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 I plus 59.54 dot 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 J. Okay, so we want the magnitude. Let's make sure I didn't reverse those. Oh, I got the wrong values though because they're both negative. So we need to change that to a negative. Okay, so both negative. Alright, so we need to do the magnitude. So equals and magnitude. So we have parentheses, this value squared plus parentheses, this value squared. Be approximate, right? Approximate. Okay, try these values out here. So the square root, parentheses, this one squared plus parentheses, this one squared. So we got 82.547. So 82.547 dot 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 pounds. So again, 30 and 60 pounds don't result in 90 pounds because they need to work together. So now we need direction. Okay, so that's our answer here. Format color orange. And format color orange. Okay, so we want the tangent of the angle, trig angle, is equal to the ratio of these values, which would be the y value over the x value. So that means that tangent, or the angle, equals the inverse tan of the ratio. Okay, so that means the theta is approximately some angle. All right, so you're like, well, how am I getting this angle? Well, if you kind of draw it out here for a second, right? You have a resulting vector here, right? FR, right? Dot 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 dot. It terminates right here, correct? Which is at the negative 57 and change, and the negative 59 and change, correct? So that means this is negative 57 dot dot dot, and this is negative 59 dot dot dot, and this is the angle I'm looking for, theta. Okay, so that's the opposite, that's the adjacent, hence why we do tangent, right? So again, this is the theta though. We need to get the bearing, which is over here. So I'm all done. I need to subtract it from 90, right? And that'll be a south by west bearing once I get that, essentially. Okay? All right, so tan inverse and ratio. We're going to put the sine over the cosine and approximate. So I get 46.1648. So 46.1648 dot dot dot, right? So we're going to say 90 degrees minus, right? Actually, put that degrees over here too. For argument's sakes, we'll say 46.165. That's close enough. Okay, so 90 minus 46.165 is 43.8835. So 43.835 degrees, right? So that's south by this many number of degrees west, because the bearing and the trig angle are not the same thing. So format, color, orange. So two vectors that are 30 and 60 pounds acting in two different directions result in this many pounds in this new direction, basically, right? Because again, if you do tail to tip, right, you're going to get this, which is the resulting vector, right? The result FR, which is this resulting vector here, which is this number of pounds, and then this direction essentially as far as the bearing. Okay.